9-7 day 1 starts on page 514, just so that you guys know. And what you're going to do for this is you're going to deal with trig identities. Okay, today we're going to be evaluating or finding some of the different ones. And then on Monday we're going to be verifying them and whatnot. Okay, so we're going to use these things for the next 2 class times. Okay, here's the trig identities that we have. The first type of trig identity that we have are called reciprocal identities. And what they are, the first one is cosecant is the same as 1 over the sine, which you guys already knew. I just didn't write it like that. By the way, when you have 1 over a thing like that, that's just the definition of reciprocal. That's what it means. So yesterday when I gave you the frequency was 1 over the period, that was really just the reciprocal of the period. Okay? So the cosecant is the reciprocal of the sine. Meaning if you know the cosecant, you flip it over and that gives you the sine, or vice versa. Right? Secant. What's the secant the reciprocal of? Cosine. And the last one of the big 3, cotangent, is the reciprocal of the tangent. Just careful not to get too close.
What?
Then it stopped recording, you know?
Oh, yeah.
Okay? Those are your reciprocal identities. So what's going to happen is, if I give you the cosecant is this number, blah, 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 then all I have to do is flip it over and that gives me the sine, and vice versa. Okay? So if I give you the sine of theta is this big, this fraction, all I do is I flip it over and I have the cosecant done. Okay? Those are the reciprocal identities. Very good. The next type of identity are the tangent and cotangent. And we'll use these, but not necessarily today. The tangent is really the sine over the cosine. And that's what the tangent is. So what do you think cotangent is? The cotangent is cosine over sine. Because they're reciprocals of each other. Right? Reciprocal just means flip it over. We'll use those more on Monday than we will today. Okay? So on Monday, we'll use those to help us solve our problems. And the last type that you are going to be responsible for are the Pythagorean identities. When I say the word Pythagorean, what do you think of? What did you say, Chandler? Okay, Pythagoras. All right. But most of you think of not that, but you think of Pythagorean theorem, right? What is the Pythagorean theorem? A squared plus b squared equals c squared. Okay? So, here's how these ones work. Sine squared theta plus cosine squared theta equals 1. That's the first one. The second one says 1 plus the tangent squared theta equals the secant squared theta. And the last one says 1 plus the cotangent squared theta equals, anybody have any idea? Cosecant. Because that's the only one we have not had in there yet. Okay? We are going to use that one, or those types, exclusively today. That's what we're going to do. We are going to use that type of mentality, using a squared plus b squared equals c squared, in order to figure out our answers today. What you are going to be doing is I'm going to give you one of the 6. Sine, cosine, tangent, cosecant, secant, cotangent. I'm going to give you one of the 6, and you got to find the other 5. It is very similar to what we did before, but it's not the x, y, and r thing. You're going to have to be dealing with the Pythagorean stuff more with this. There's only 4 questions. I'm only going to give you 4 problems to do today. Okay? So here's how it's going to work. The questions that you're going to see today are going to look like this. It's going to say the sine of theta equals 4/5 and pi over 2 is less than theta, which is less than pi. Find the values of the other 5 trig functions. That's the whole directions for today. This is how it is. Now, this stuff in the back, this pi over 2, theta, and pi, that's just telling you what quadrant we're in. Pi over 2 is the same as 90 degrees, and pi is the same as 180 degrees. So we're between 90 and 180. So what quadrant is that? 2. Okay, when you look at this particular thing, this would be 0, this would be pi over 2, this would be pi, and this is 3 pi over 2, and this goes back to 2 pi. Don't bother me. Okay? 1, 2, 3, and 4. We are in quadrant 2 when it says this restriction. What's so important about quadrant 2? Well, we have negative which way? To the left?
Yeah.
But not up, do we?
No.
Okay. Sine curve, or sine says 4/5. The easiest one to get rid of would be, what's the reciprocal of the sine? Cosecant. So let's get that one out of the way. What's the reciprocal of the sine? 5/4. Because the reciprocal of what they gave us, the sine was 4/5. So the reciprocal of that is 5/4. You just used the reciprocal identity. That's what you used. Good job. Now, the next thing that I want you to do is look back at your identities that I gave you. These deal with just those two, and those 2. Right now I have these 2 done. I don't have any one of the other 4 done, nor can I bridge the gap over. You are not going to use the tangent and cotangent ones today because they don't necessarily work for this particular context. But you are going to use this one. So, looking at the ones that you have, right now you have the sine given to you and you have cosine, or cosecant given to you. So which 2 do you think we're going to use? The first one and the last one. What's the first one going to find us if, Tamara, I already know the sine? What is it going to give us then?
Cosine.
Good. It's going to give us the cosine. So here's how it works. The formula is sine squared of theta plus the cosine squared of theta equals 1. Tamara, how big is the sine? 4/5. Good job. So 4/5 is going into here, squared plus cosine squared equals 1. Now, for a lot of you don't like fractions. Well, too bad. What's 4/5 squared? So when you do that, do 4 squared and then 5 squared. 16 over 25. Awesome. Plus cosine squared equals 1. How do I get the cosine by itself? subtract 16/5 over. Very nicely done. Now, when you do that, when you take a 1 minus 16/25, when you're adding and subtracting of fractions, you need to get a common denominator. What would a common denominator be between 1 and 25? Right. So this really is 25 over 25. Because I would have to multiply it by 25 to both the top and the bottom. So then 25 minus 16 is 9 over 25 equals the cosine squared of theta. How do you get rid of square? Take the square root of it. How do you square root a fraction? You do the top and the bottom separately. So therefore, the cosine of theta, what's the square root of 9? 3. And what's the square root of 25? 5. You just found the cosine. Yes. No, but you should have it there. So once you know cosine, you also know what else? What's the reciprocal of cosine? Not cosecant. Secant. What's the reciprocal of the cosine? 5/3. Right. Okay. You did great so far. But what else do we need to do? Now I got to find the tangent and cotangent, which again, you got to use those Pythagorean identities. You've got sine, you've got cosine, you've got secant, you've got cosecant. What other one would give us the tangent? The last one you guys said we were going to use, right? Because it said cotangent. Could we now use the middle one? Yeah, because we do also know secant. So now all of them are fair game. So which one do you want to do? The last one? Or the last one first, sorry. I'll let you lose. So 1 plus the cotangent of theta, squared theta equals the cosecant squared of theta. What was the cotangent, or cosecant? 5/4. All right. What is 5/4 squared?
16. No, 25 over.
You guys said 5/4 for that, right? Okay. Now what? Subtract 1. How do you add and subtract fractions? What is the denominator right now of the 1? Well, it needs to be 16. It is 1, right? So what do you multiply it by, Allie, to give me 16? Yeah. So it ends up being 16 over 16. What's 25 minus 16? 9. And what's the bottom? Good. So I have right now the cotangent squared of theta equals 9/16. Now what? Square root it. And when you square root that, what do you get? So what's the tangent? 4 turds, right? So you found all 6. Yay, team. But there is a big but. It's not that you did anything wrong. The numbers are okay. The only bad thing is that we were supposed to be in quadrant number 2, right? Which means some of those should be negative and some of them should be positive. If it's in quadrant 1, all of them are positive. Shouldn't matter. But with this particular thing, because we were in a different quadrant, we should be getting some negative numbers. Okay? Because we were in quadrant 2, the cosine is negative. If the cosine's negative, what else should be negative? The secant should be negative. What else should be negative if the cosine is negative? Cotangent, and also then the tangent. Now, how did I know the cosine was negative? What was the cosine when we did the right triangle trick? Left was negative, right? That's the adjacent side. And then positive. So negative. That's why the cosine was negative, because we went left first. Okay? That goes back to what we had the first half of the chapter. Sometimes you have to remember what you did a couple weeks ago. This is what you're doing today. You have 4 problems just like this, identical to this. The only difference is the numbers change, but realistically it's the same thing. Do you want me to do another one? It's a whole lot of Pythagorean theorem. That's what it is. So, on page 517, 3, 5, 7, and 9er.